Alrighty, here's part 2. So vector UV as a component vector would be -5 minus 1 is going to be -6. 9 minus 5 is going to be 4. Okay, so now that I have that, the magnitude of UV is the square root of -6 squared plus 4 squared, which is the square root of 52, which gives me 2 square roots of 13. So my magnitude of vector UV is 2 square root of 13. My angle, theta, that's the tangent inverse of B over A, so that's 4 over -6. Not an angle I would know, so I use my calculator, and I get that theta is 146.310. Everything is always to 3 decimal places unless you are told otherwise. All right, number 13, same thing here. So my component vector, -3 minus a -8 will give me a +5. -1 minus 5 will give me a -6. So my magnitude, Mn, is going to be the square root of 5 squared plus -6 squared. The square root of 25 plus 36, square root of 61. Cannot simplify that, so the magnitude of Mn is the square root of 61. Theta, that's the tangent inverse of -6 over 5. So I just put that in my calculator. Calculator is going to give me -50.194, but this is, oh, I need to go back up to the other one. I just realized I zipped past that. My calculator didn't actually give me 146 up here either, so I'll come back to that. But this is what my calculator gives me. This is a 4th quadrant angle. Sorry, I skipped over that. And so this is a 4th quadrant angle already. If I want to stay in the 4th quadrant, I add 360 to that, and that gives me that theta is 309.806. Sorry. I was just trying to save you time with me actually pushing buttons on the calculator. So up here, what the calculator actually gives me here, and what it should give you, is -33.690. So that puts it here in the 4th quadrant somewhere. This is a 2nd quadrant vector, so I need to add 180 to that. So when I add 180 to this in my calculator, that's where I get that 146 from. Alrighty, so let's look at 14. Since 14 is already drawn for me, I can see that it's pointing towards the 4th quadrant, so it's going to be a 4th quadrant angle that I need. I need the component form, so to get from here to here, I'd go to the right 3 and down 1, 2, 3, 4, 5. So this is 3, -5. Okay, sorry, I got interrupted, so I don't know what the last thing I said was. But we got this in the component form. So then I got to find the magnitude of vector k. This is the same. I gave you 4 of like almost the exact same questions. So this is 3 squared plus -5 squared. This is the square root of 9 plus 25. Which gives us a square root of 34. So the magnitude of vector k is the square root of 34. The direction angle, theta, that's the tangent inverse of b over a, -5 over 3. So my calculator gives me -59.036. So that puts me down here in the 4th quadrant of my circle. I do want to be in the 4th quadrant, but I don't want it to be -59, so I have to add 360 to that. So when I add 360 in my calculator, I get that theta equals 300.964 degrees. Alrighty, number 15. When I want to add c plus a, that means that this is going to be -6 2 plus 4 -1, and that will end up giving me -2 1 for my vector. Then 2 times times vector 3, 5, minus 5 times 4, negative 1. So 2 times 3 is 6, minus 5 times 4 is 20. So 6 minus 20 is going to be a negative 14. Then 2 times 5 is 10, minus, and let's see, negative 5 times negative 1 is a positive 5, so it's really 10 plus 5, and I get 15. Right. Then negative a for negative 1 plus half of c, which is negative 6, 2. So it's going to be negative 4 plus negative 3, which will give me negative 7. And then that makes that a positive 1 plus 1, which gives me 2. All right, so to find the component form of each vector, the given magnitude and direction. So I have the magnitude and the direction. So vector D then, that is going to be 12 times the cosine of 330 and 12 times the sine of 330. Okay, so I got to think about what 330 is. 330 is 30 away from 360, so that means it's a pi-sixth angle. That would actually make it 11 pi-sixths. So I know then that the cosine in the fourth quadrant is positive, and the cosine of pi-sixths is the square root of 3 over 2. So this would be 12 times the square root of 3 over 2. Then the sine of, in the fourth quadrant, is negative, so that would be 12 times a negative 1/2. So in the end, vector D in component form is 6 square root of 3, negative 6. So then I'm going to do the same for this one. For vector V, this is going to be 8 times the cosine of 215, and then 8 times the sine of 215. All right, so 215 is not a special angle, so this is just going to go directly in my calculator, and I will get that vector V is negative 6.553, negative 4.589. Right, if I want to write this in trigonometric form, the first thing I'm going to do with number 20 is to put it in component form, which would be negative 2, 6. Then I'm going to have to find the magnitude of vector n. It's going to be the square root of negative 2 squared plus 6 squared. So that's going to be the square root of 40. I need to simplify my square roots, so that is 2 square roots of 10. So that's the magnitude. I need my angle. So this is the tangent inverse of 6 over negative 2. That would be a negative 3. That's not a special angle. So that gives me negative 71.565 in my calculator. But this vector, if I'm going to go negative 2, 6, that's a second quadrant vector. So this puts me here. If I want to be in the second quadrant, I add 180. So my theta is actually 108.435. So my vector in trigonometric form is going to be 2 square root of 10 times the cosine of 108.435, and then 2 square root of 10 times the sine of 108.435. Okay. Then for number 21, I'm going to need to get it in component form. So it's going to be negative 4 minus a negative 5. That'll give me a positive 1. 6 minus 2 is 4. So this is a first quadrant. My magnitude of xy is the square root of 1 squared plus 4 squared is equal to the square root of 17. Theta is equal to the tangent inverse of 4 over 1. Not an angle we know, so that is 75.964 from the calculator. That's a first quadrant angle. That's what I want. So then xy is going to give me square root of 17 times the cosine of 75.964, and then the square root of 17 times the sine of 75, sorry. 75, oh my gosh, I still can't write it. 75.964. All right, 22. Mother is pushing a stroller with a force of 30 pounds uphill at an angle of 25 degrees. Give the force exerted on the lawnmower as a vector in component form. Okay, so she is pushing a stroller uphill. Here's my vector, angle of 25 degrees, force of 30 pounds. So that means my vector is 30 times the cosine of 25, 30 times the sine of 25. So once I put that in the calculator, I get 27.189, 12.679. Okay. 23. A sailboat is traveling at 6 knots on a true bearing of 220 degrees. Give the velocity of the sailboat as a linear combination. Okay. True bearing. 220 degrees. As I start here at 0, this is 90, 180. This will go all the way to 270, so 220 is in here somewhere. All right? Here's my vector. This was 220 degrees. I know that if this is 180 right here, then this part right here has to be 40. I need theta. Theta starts here. That would be 180 plus some. If this is 40, this is 50. So it's going to be 180 plus 50, and that would give me 230 degrees. That is theta. All right. So my vector is going to be 6 times the cosine of 230, 6 times the sine of 230. And then I type those both in the calculator, and that gives me the vector is negative 3.857, negative 4.596. In linear combination form, that becomes negative 3.857 plus, I hat, plus negative 4.596 j hat. Or it could be minus instead of plus and negative, either way. But that is my answer. Okay, number 24. I have two forces with magnitudes of 115 pounds and 160 are acting on an object at angles of 50 degrees and 130 degrees respectively. Okay, so 115 and 160 acting on an object. Let's see, got angles of 50 degrees and 130, and so these are just plain old angles. So I have an angle of 50 and an angle of 130. This is a magnitude of 115, and this is a magnitude of 160. I want to find the magnitude and direction of the resultant force. Okay, so the first vector is going to be 115 times the cosine of 50, 115 times the sine of 50. The second vector is 130 times the cosine of 160, 130 times the sine of 160. All right, so then I'm going to add the two vectors together. And my calculator, remembering I'm going to need these numbers. Okay, so careful how you do it. I showed you in class how to manipulate the calculator. If you have a different calculator, do it a different way, whatever. But the calculator gives me negative 28.925 and 210.662. So that's my resultant vector. I now need the magnitude of that resultant vector. So that's the square root of a squared plus b squared, so this squared plus this squared, but I don't type the decimals back in, and that gives me 212.639 pounds. All right, then theta is the tangent inverse of b over a, so b over a. My calculator gives me negative 82.182. So that puts me here in the fourth quadrant. Got to figure out where I really want to be. This is negative positive, so that's actually a second quadrant angle. Since I'm in the fourth quadrant, I want to be in the second quadrant. I add 180. So when I add 180 to that in my calculator, I get 97.818 degrees. Okay. All right, 25. We have two pulleys lifting a statue. One pulley is pulling with 575 newtons of force at an angle of 35 degrees left of the statue. Okay, so we're going to make this the statue. We have a pulley pulling with 575 newtons at an angle of 35 degrees left of the statue. So this is 35. This is 575 newtons. We will make this vector 1. Then second pulley 30 degrees to the right. So this is 30. This is 700 newtons. And we will make this vector 2. Okay, so for vector 1, if this is 35 degrees, I got to add that 90 there. So this whole angle, so theta for vector 1 is 125 degrees. Theta for vector 2, if this is 30, this right here has to be 60. There are my two angles. So my first vector is going to be 575 times the cosine of 125, and then 575 times the sine of 125. Vector 2 is going to be 700 times the cosine of 60, 700 times the sine of 60. Then I'm going to add them together. That gives me, and being mindful again of my answers in my calculator, it's going to give me 20.194 and 1077.230. This is positive, positive, so this is a first quadrant. I will need a first quadrant angle. I find the magnitude, V1 plus V2. It's going to be the square root of a squared plus b squared, which will be a squared plus b squared, the exact numbers from my calculator, and that will give me, oops, no it doesn't. It gives me 1077.419 newtons. Then I find theta. That's the tangent inverse of b over a, so this number over this number. My calculator gives me 88.926 degrees. This is a first quadrant. It's what I want. That is the first quadrant. There's my angle. Okay, let's look at 26. I have an airplane that is traveling at a speed of 450 miles an hour in the direction of north 54 degrees west. Okay, so there's this. I'm going to go north 54 degrees west, something like this. That makes this 54. Makes this 450. And while flying, the airplane hits wind, traveling at a velocity of 55 miles per hour. So I'm going to have to add that vector to this one. And that is at south 70 degrees west. So like this. So this is 70 degrees right there. And this is 55 miles per hour. When I add those two together, vector looks like this. So this first theta, so the theta for the plane, so we'll do the plane and the wind. Theta for the plane vector, let's see, this is 54 degrees right here. I have to add 90 to that, so that'll be 144. Then theta for the wind, if this is 70, that makes this 20. So 180 plus 20 would give me 200. Okay, so my first vector, or for my plane vector, that is going to be 450 times the cosine of 144. 450 times this, 450 times the sine of 144. The wind vector would be 55 times the cosine of 200, 55 times the sine of 200. Okay, so then I would add those together. My plane vector plus my wind vector would give me negative 415.741, 245.692. Okay. So I would have the magnitude, of the plane plus the wind. It's going to be the square root of a squared plus b squared, so that gives me 482.913 miles per hour. My angle, theta, is the tangent inverse of b over a, which the calculator gives me negative 30.582. Okay, unit circle-wise, that puts me down here in the fourth quadrant, but this is negative positive, so I actually want it to be in the second quadrant. So to get to the second quadrant, I'm going to add 180. So when I add 180, I get 149.418 degrees, but this says as a true bearing, so I need to think about what that means. This 149 is going to be this right here. What I want is a true bearing that starts here and goes around this way, which is different than a quadrant bearing, which you also need to know how to do. So if I want the true bearing, I know that this is 90, 180, 270 plus however much this is. Well, this part right here would be 180 minus this number. 180 minus this number gives me 30-something. That's this part. I add that to 270, and my true bearing is 300.582 degrees. There you go. If I had needed a quadrant bearing, then I could have just subtracted 90 from this and done a north, whatever, 59 degrees west. But there's your true bearing. Make sure you know the differences between those.